Right, good day and welcome. I'm Mr. Simons. Today's lesson we'll be learning the basics of sine graphs, specifically looking at A sine A. Right, so we're starting from grade 10 and working our way up to grade 11. So y equal to sine A is given. To plot this function, we will set up a table. We will make use of our calculators to find the corresponding y values. So here we're specifically looking for A. We will be testing from 0 degrees till 360. That technically is my domain, my permissible values of x. So if I punch in sine 0 degrees, my y value is 0. Sine 45, I would get 0,707 or 1 over square root 2. Sine 90, give me 1. Sine 135, 0,707 sine 180 would give me 0. Sine 225, negative 0,707. 270 would give me negative 1. 315, negative 070, and 360, 0. Now I haven't set up my Cartesian plane properly, but there's my y values going 0, 0,5, 1, 1,5. This here should read 0, 45, 90, 135, 180, going in that order, right? So if I plot, there's 0 and 0, 45, 0,70, 90 and 1. The 90 and 1, as you can see, it tips again to 135, 0,70, 180 and 0, 225, negative 0,70, 315, 270 minus 1, and 360. And I simply join all my dots and I have a basic sine graph. Now sine graphs automatically in physics you should have done grade 10 transverse wave, right? Transverse wave, where that's referred to as a crest and this referred to as a trough, right? Also used in oscilloscopes, etc. And there's many functions, the trig functions that we're doing. Sometimes we use it as horizontal and vertical drilling, in fitting and turning, make use of it in civil engineering, etc. Sound waves, you name it. Right, so hope you understand and follow. Right, let's look at some general features. So general features, right, now take note there, I've typed in 1, we don't need to write the 1 there, no? But there's an invisible value 1 in front of sine. That gives me my amplitude. So what do I mean with amplitude? Right, if we start here, draw a horizontal line, amplitude is the highest point the graph would go to, starting from 0 to 1. Right, so my amplitude is 1. Therefore, the maximum value there that the graph goes to is 1. The minimum value there is minus 1. My range, as you can see, it's between 1 and minus 1, my graph. So y greater or equal to minus 1, less or equal to 1. The period is the amount of degrees for complete sine graph. So that's one complete sine graph. So I drew from 0 till 360 degrees. Therefore, my period is 360. Also note, from functions, you should have learned, it's decreasing functions here. This graph is decreasing from 90 degrees here till 270. Reason why we say so, the x values here are increasing, getting bigger and bigger, but the y values are decreasing as the x values get bigger. So therefore, decreasing function. Alright, now this that I've done here, I'm going to be doing other examples now. I hope you pick up this, just a general pattern. Once you get used to it, no problem. You'll see the graph always starts there, goes up, turns, goes down, turns, back there. Always in between the range we're going to find. Right? And I just want to give a special shout out to Ali, Mr. Shah. I'm impressed with your scientific knowledge, especially on planes and aircrafts, so on, and I know together we will master maths and become better. All I ask of you, stay motivated, remain dedicated, persevere. Sky is the limit. With enough practice, you can master anything in maths. I believe in you. Right, let's look at the next problem. So here we have y equal a sine a, given y equal 2 sine a. So value in front of sine a is 2. Therefore, my amplitude is 2. My amplitude is 2. Maximum value is 2. Minimum value minus 2. Therefore, the range y greater or equal to -2 and less or equal to 2. Period for grade 10 will always work with 360 degrees. To plot it, again, my interval spacing, I just say 360 divided by 4, which give me 90 degrees. So therefore 0 plus 90 plus 90 plus 90 plus 90. So sine 0 or 2 sine 0 is 0. Sine 90 is 1 times 2 gives me 2. Sine 180 is 0 times 2 stays 0. Sine 270 is minus 1 times 2 becomes -2. Sine 360 is 0. So if I plot, there's 0 and 0. Then I go to my maximum value, which is 90 and 2. Come back to the middle there, 180 and 0. Go down below, 270 and -2. And there 360 and 0. Plot those points, then we join a line through it. Take note of how the graph curves. There technically, yes, I'm supposed to draw a horizontal line. My apologies, I forgot, but there would be 0, 90, 180, 270, 360 degrees. So I hope you pick up the pattern there. How I've gone from the values given to get amplitude, max, minimum value, range, and period. Right, so maximum value, highest point, y goes to, minimum value, lowest point on my y-axis. Right? Period, how many degrees it takes to complete one complete sine graph, so it must always have a crest, and a trough or bottom and a top part. Right, let's look at the next problem. Now there y equal a sine a. So again, in place of a, I've written 3. So if you're picking up the pattern now, that 3, amplitude is 3. So my amplitude is 3, my maximum value must be 3, and the minimum must be -3. My range must be greater than equal to always the smallest value on the left, which is -3, the biggest value on the right, which is +3. Again, period is 360, so if A is given there, angle A, 360 degrees. To plot it, we're going to use again my interval spacing, 360 divided by 4, gives me 90, so 0 plus 90, 90 plus 90, 180, 180 plus 90, 270, 70 plus 90, 360. So sine of 0, 0, sine of 90 times 3 would give me 3, 180, 0, 270, sine 270 minus 1 times 3 gives me -3. 360 would give me 0 times 3, which is 0. So that you can all find on your calculator. You see the graph still looks the same as the two previous ones I've drawn. Only difference is now, my highest value now is 90 and 3. Alright, that's 180 and 0, 270 and -3, and 360 and 0. Just for interest sake, I assume you know, every time you put your sound system at home or your phone, you put your phone louder. To change the loudness, you are changing the amplitude. So when we measure decibels, we are actually measuring the amplitude of a wave. Right? So the higher the wave goes, the louder sound becomes. That's just a basic application of it. Right? Trig functions is very important in real life. And trigonometry in general is used not only in civil engineering to do slopes and so on when we curve roads, etc. To also use it in fitting and turning for horizontal and vertical drilling. We use it in sound, as you can see. We also use it basically check heartbeat, pulses, etc. Alright. I wish you nothing but the best. God bless. Bye.